Hey there, folks. So, in the last episode, we started the setup for our save game functionality, and we ended off here with our gather actor function, and we were just getting to the point where we needed to start pulling in some information. So, with that, though, as I had said, we do need to cover the specifics of the save actor interface that we created, and we're going to do that now to start with. So, let's go over to that interface. Now, for anyone unfamiliar with Unreal interfaces, we don't do any work in the U save actor interface. We do it all in the I save actor interface. So, first things first, we want all of these to be public, so everything is going to be down here in the public section. Now, because we are going to be exposing all of this to blueprints as well, we do need to take that into consideration. So there is a slight change in how we're going to be formatting this functionality compared to what we've done so far in the series. So first of all, we're going to start with, let's get back to game instance, this very first function here of get the actor ID. So what we need to do here is U function. And this one we're actually going to call a blueprint native event. And what that means is the function we declared directly below it is something that is going to be implemented through blueprints. And in this case, it's going to be an fguid get actor save ID. That's all we need to do there. Now, we do need to expand this so that it I shouldn't say expand it. We need to effectively duplicate this so that we have the same thing at a C++ level. What we're going to do here is virtual fguid get save actor ID, but then for the purpose of the Unreal Engine compilation and editor, we need to do something slightly different, and it's underscore implementation. And what this does is it tells the editor that this is the C++ version of the call, and if we're using this, we're using the blueprint version of the call. So that is the first one, that is get save actor ID. And as I mentioned, we do not need to do anything with this blueprint one, but we do want to add some basic information for the get save actor ID information. We want a default. And what we're going to do here is fguid ret equals fguid. And then we're going to go ret.invalidate. And then we're going to return ret. So the whole reason we're doing this is this is the default function. If your the actor that you're using this interface on doesn't have this function defined, it's going to fall back to this. And we don't want it providing a valid GUID. So now the next thing we're going to want to do is we are going to want to cover the get save data function. So we're going to again go back to the save actor interface into the header file, and we're going to do basically the exact same thing here. We're going to go U function blueprint native event f save actor data get save data, and just like before, virtual f save actor data underscore implementation. Casing is important here. Implementation. There we go. And we want to do the same thing here, except we don't need to make sure the data is invalid. We just want to return the default. So that right there is all we need to do. So now we have these two functions. We're going to actually want to add this interface onto our base character class. So we're going to go to tf character header file. We are going to want to grab the include save actor interface header Let's go back to the character file, put that in the right place. And we're going to throw that in there. And for this, sorry, brain fart for a moment there. So for this, we want to go add public iSaveActor interface. And what this is going to do is this is going to tell the compiler that this class uses the iSaveActor interface. So anything that we have at a game level running with, well, any base class from here, and that includes a player character, is going to have this interface. So what we want to do now is we need to add these in as functions within this class. So the first thing we want to do is in here, we want to go back to we want to grab this and add it to here. And we want this to be public again because the functions within the interface itself are public. These need to be public as well. And as I mentioned, we don't need to include this because we're doing it at code level. So we want to use the implementation method. And we're also going to add in a get save data implementation. So with that, first thing we want to do is go to, sorry, give me 1 second here. I'm just looking at my notes on this one. I want to make sure I'm getting this information right. Okay, so the first thing we're going to want to do is we want to make sure this actor has a GUID. What we can do is up here, and I broke my own rules there. So anyways, so we want to go U property, visible anywhere, blueprint read only, because we don't want this to be changed. And we want to go F GUID save actor ID. And then what we want to do is over in the source file, as part of the constructor, we want to go save actor ID equals F GUID new GUID. And then literally all we have to do is back in here, create a definition, and return save actor ID. So now what this is going to do is whenever you put a copy of this actor into the world, it is going to generate a GUID for it. One other thing I like to do is, as part of the begin play, I add this in as if save actor ID dot is valid. We don't want to do anything. We want, if it's not valid, we want to and what we've done here is this is just a precautionary fail-safe. If for some reason this line of code is not executed, we're going to give it a GUID when we begin play. Now, I was initially concerned that maybe you're going to run out of GUIDs, but as we've seen in the last episode, there is such a large number of GUIDs, the chances of that happening are minuscule. So the next thing we're going to want to do is create an implementation for the get save data. So in here, we're going to go F save actor data ret. Now I just use the name convention of ret as short for return, and then that means well, and that's just because it's easy to keep that consistent across all of these functions. So ret dot actor class equals this. Where's this pointer? Yeah, no, there's a pointer. Get class. Returns to the U class. Yeah. And ret dot actor transform equals this dot get transform. And then this is also where you would put in any additional data you may want to add. We don't want to do anything with byte data yet. That is going to be covered at a different point. Now, there is that one other value here, was spawned. So we don't have any way of storing that. So what we're going to do here, no, that's because we don't have that in there. We're going to also add in bool was spawned equals false. And ret dot was spawned equals this dot was spawned. So right now we've got this basic information here. So from that, we are able to now continue with this logic. So for that, our next step here is going to be fguid save actor. Actually, I'm going to shorten this one. Save actor ID equals enter get save actor get actor save ID implementation. And then if not valid, so if this is an invalid GUID, we just want to continue again. And the reason for this, and I'll just explain quickly, is every time we hit a point where something isn't valid, you can do something like add logging here to say we've pulled an actor with an invalid GUID, and that's up to you. I'll be doing that later on in the series when I get to the logging section. But the whole purpose of these checks are, okay, is this valid? No. Let's go back to the next one. Same thing here. Is it valid? No. Back to the next one. It helps speed things up so that you're not wasting time processing a lot of additional information before you realize your information is bad. Like we know at this point, if it doesn't have a valid GUID, we're not going to be saving it. So just move on to the next one. Now from that, we need fsave actor data. And I'm just going to call that sad. And that is actually going to be equals enter get save data implementation. Now this is where, as I mentioned in the last episode, we're following that tutorial from Tom Looman. This one is where we're going to start populating that byte data. And the reason we're doing it here instead of within the specific actor itself, like in here, is for the purpose of we don't want each individual actor knowing about everything it needs to save, things like that. We're going to bloat this class, and it's going to add a lot of like unnecessary overhead to the base character class. Whereas if we add it to the game instance, we have to define it once, and it's only sort of in memory once, and ultimately it helps just reduce the overall memory footprint. So anyways, going back to this, we do need to add a new include in here, and this is a bit of a weird one. It's pulled again, like I said, directly from that tutorial. It is the serialization object and name as string proxy archive. That's a mouthful. I'm not quite sure why it's named like that, but so down here we need to establish an f memory writer. And we're going to call that mem writer. and we want to instantiate that using the byte data that's in our save actor data. Actually, I'm going to move this into its own line so we know it's a slightly different section of code. Next, we are wanting to grab an F object name and string proxy archive. We're going to call that AR for archive. We want it to be instantiated with the memory writer, and we want it inload if find fails. We want true. Next, we want to define a property. So AR is save game. We want that to be true. And what this is basically saying is any property that has the save game attribute. Now, we haven't defined any of those yet. We're going to do those in a moment. So once that's done, we want actor serialize AR, and then what this does is it's going to grab all of the savable information, serialize it for us, and actually push it back into the byte data of your save actor data. Now, the last thing we want to do is savable actor data. What would I call that? SAI, save actor ID, equals save actor data. Now, normally I don't like using these acronyms. However, the descriptive name is very long in this case. So, and ultimately, that's the basics of the gather information or gather actor data. So now there is going to be certain things in here that this isn't going to catch. And that is where I was mentioning how let me pull that back up. In here, you're going to want to potentially add in some additional storage data. And again, the whole reason for that is because there is certain things in here that are not going to be saved by this process. So now, before we get too carried away, let's just do a quick build here. Make sure all of this works and I don't have any code errors. And this is going to take a moment, so I'm going to pause and I'll be right back as soon as this is done. All right, that build's finished. Took a little longer than expected, but we are good to go there. So now this is just the basics of the save system. As of right now, all this would save is our player character's location or transform. None of the other information would get saved. What we need to do is start defining some additional attributes that need to get saved. Now, those can be saved by, so here we want to go save game. We want to add this particular attribute to our U properties. So, and what that is going to say is, was this spawned? It's going to save whether it's true or false. We don't really need to save the save actor ID, but just in case, we will. We're going to add that to our stat line component. Oh, the parsing is going through. There we go. Now we're going to go also into the stat line component. This, however, from my personal experience, isn't going to save anything, but we will add these in just in case. And then close out this struct. In here, we want these to be save game. And that should be all of them. So what we're going to do, though, is we're going to need to add some functionality into the game instance for, at least quickly, that is going to allow us to actually test this. So what we need to do here is add in U function blueprint callable void save game. Actually, I'm going to do this the other way around. It's dev save game. And that is just something I've added in as a development call. And that is a perfect reason for this prefaced dev. And actually, I'll do that. So we're going to quick action, a refactoring, create a definition. So what we want to do in here is, let me just pull up how I had this before. Again, I'd prefer to keep my notes, so I'm not, or looking at my notes so I don't mess up anything. So in here, this is if save game object equals null, and this is that null pointer checking I put in before. Save game, nope, we have that create save slot. And then we're going to call gather actor data. And then we're going to go save game object, add save, what is it? Save actor, set save actor data, and that's savable actor data. We're not going to worry about the current level, but that is something you would want to do in here. You'd want to set the current loaded level as well. And then you want to call u gameplay statics save game to slot. You want to pass in your save game object, save game name, and then the user index. And again, for a single player game, you don't need to worry about things like the user index. It will always be 0. All right, so now we've got that. Let's build this quickly. This shouldn't take too long to build because we've only added a couple things, but apparently it's taking 13 actions. So, well, we did add all the save game tags. So I'm going to pause this quickly, and as soon as this is back built, I will be right back. All right, so that's built. We're actually going to run the editor from Visual Studio this time because we do want to add a breakpoint in here for when we call this save game function. I just want to actually check. Yes, I made that as a blueprint callable function. So I will be back as soon as the editor's loaded. I know this can take a few moments to load up, and we will move on with the next step. All right, folks, we're back here in the editor. So there is one more thing we need to do before we can actually get this all set up. So we bring the content browser over when it decides to wake up. There we go. No, not going to let me move it. There we go. So in here, we're going to go into the third person folder. Actually, no, we're going to create, it's our own folder. So in this case, underscore GCG for Gas City Games. Open that up. And in this case, the project name, which is the fall. Blueprints. Oh, come on. New folder. Game. So in here, we're going to blueprint class. All classes. TF game instance. Select. Now, one of the reasons for this is later on when we are doing level loading, I have found at a C++ level, the level loading code just doesn't work. You need to do it through blueprints. It's actually been a reported issue to Epic, and I still haven't seen it being fixed, but we will see. Anyways, game, actually, let's game instance. So we're going to save that, and then edit, project settings. Come on. There we go. Game instance. And we have it here, BPTF game instance. All right, so we're going to go back to the third person blueprint. And we are just going to add in a debug functionality here once this loads up for calling that save logic. So key down, keyboard events, sorry. Keyboard events, and we're going to use 7. That's num7, f7, 7. So what we've done here is when we have pressed the number 7, which is the key above your y/u, not the numpad. So game instance. Anim instance, get game instance. We're going to cast to tf game instance. I'm going to convert this to a pure cast because we have already defined that. And we want to call the dev save game function. So I'm going to do that. Now what we're going to do here before we go through and actually hit this key, move this out of the way, go back to Visual Studio quick, just make sure all of our breakpoints are in the right place. Game instance, yep, we have this here, so we should hit this breakpoint once we hit the number 7 key. So play. All right, so we're in game. It's a little clunky. So 7. There we go. We've hit this breakpoint. So you can see, so that's null. It's going to go into the create save slot. Object is null. Now we have a game instance. Save game object. Now we're going to go into the gather data. So for f-actor iterator get world, we'll just step through some of these. So the actor here is world info. If it's valid or it doesn't implement that, skip over it. It's a brush. It's a cube. Actually, let's add a watcher so we can make going through this a little easier. So we're just going to step through. It's cube 4, cylinder 13. And then what we're going to do, just for our own instance, I'm going to throw a breakpoint there and hit continue. So now you can see it has pulled up BP third person character because that implements the save actor interface. So I'm going to cast, enter is valid. It's not a null pointer. Okay. So you can see before we do anything, it's all zeros. And now it's got a GUID. With the player character, we're going to be changing this logic a bit. Just simply because the player character is going to be something that is 100% always spawned at runtime. So this GUID is always going to be changing. Like you can see here, it's 385F is the last few there. Okay, and then save actor data. We can push out 11 in here, go through. It's not going to give us the ability to step through anything here because it's an interface and it's going through its first iteration. Second iteration through, we can look at this and go, is it going to let me? Nope, we'll have to do it when we get back into here. So you can see for that, we have the actor transform. It wasn't spawned, and we can have actor class, BP third person character. Okay, and of note here, just notice byte data is empty. So we're going to go through, create the memory writer, do that, assign that. We're going to serialize. Now let's have a look and see, is there anything else in there? Well, now byte data has a lot of additional information in there. And honestly, I'm not going to go through all of it because there's a lot there, but you can see it's added a bunch of stuff. Some of the information like stat line, object property, so on and so forth. So now we're going to hit F10 just to go through one more. And now we've actually hit one of the mistakes I made in the code. And hitting this reminded me it's not that this was not planned. This is me being a C++ developer by trade. I was using default C++ logic. What we have done here is we're just assigning. It's already empty. With Epic, or Unreal specifically, you actually need to add save actor ID, save actor data. And this is something, again, like I said, this is one of my mistakes. I was using normal C++ logic with mutable maps, but because this is a Unreal specific T map, you can't just push stuff in. So we have to fix that, which also means we need to fix it in save game. Nope, that wasn't save game. It was the add actor. Where is it? This one here. Dot add. Actor ID, actor data. So, all right, so now we've fixed that. Let's build this again. And we'll continue debugging through all of this. I'll throw a breakpoint there just so it's, when we're going to add it, I can hop through to that quickly. This built really quick because it was only a very minor change to the game instance class. Hopefully this actually launches the editor quickly. We'll see. And there we go. Launch that pretty quickly for a change. Quickly check to make sure is that logic still there. Yes, it is. So close out, play an editor. I'm gonna go move over here. Let's run up here and hit 7. So we're gonna go through save object is null. It's gonna create one. Gather actor data. I'm gonna just jump through to the continue. And in this case, we can see the actor is BP third person character. Let's go through and get that. And here you can see that GUID is different. And the reason being is this was the player character spawned at runtime. It's not an actor you take possession of in the world. With that, as I mentioned a little later on, we are going to be fixing this logic so that it is always using a specific data store for the player. But right now, we're just going through the basics of the save system. So we've got that. Let's just continue to this next one. So savable actor is empty. Now it's got one actor in it. So we're going to hop out. No, not letting me do that. Put that one there. So continue. So we have gathered that. Savable actor data, there's one in there. Save game object, set save actor data. Push that through, and then we're going to save. And there we go. So we have saved that. Well, we don't have any load functionality, but that's a start right there for showing how the save game system works. Next, we're going to add in that load functionality. So close out of this, and actually we're going to shut down the editor. So now for that load functionality, and that's actually going to be the last thing we do here in this episode. We do need to add a new function to the game instance. Sorry, just what we're going to do is add this as a private function, void load game, and create a definition for that. And this one, the reason being it's a private function is we only want to call this when certain things have been set, like the level name and everything like that. Oh, sorry, the save game name, not the level name. So what we're going to do here is if u gameplay statics does save game exist, save game name for user index 0 and not bracket. And we need to close that out. And just like everything else, we're going to put a negative. If it doesn't exist, we want to just return. And in here, we'd want to go to do add logging and error message about missing save game. So now that we know that that save game exists, what we can do is load that information. So with a loaded game, you want to make sure none of your potentially previously saved information is retained. So what we need to do here is savable actor data dot clear, or is it empty? Empty. Remove all the elements from the map. Yeah, sorry, dot empty. And what that does is that clears any information that may have been stored on your game instance and resets everything there. So next we want to go save game object equals cast to U save game U gameplay statics load game from slot, and it's the save game name for user index 0. Next we want to pull out that information, so we're going to go savable actor data equals save game object and get save actor data. So again, if you're using multiple maps and things like that, you'd also want to in here call get current level load current level, and you'd want to do things like that. So now the next thing we need to do is actually, then there's going to be some stuff we're doing here that's not critical right now, but it's better to get this in place now than wait until later. So what we're going to do is for t-tuple fguid fsave actor data side in savable actor data. So what we're doing here is we're iterating through every single instance in that saved information we just loaded. And what we're going to be doing here is if that saved actor data value, so that's pulling up the information from the save actor data itself, not the tuple, not the key, sorry, and then was spawned. So what we're doing here, this is for, as I've mentioned before, the spawned at runtime actors. And there's a reason for this. I will cover that shortly. It's better, going to be easier for me to explain that after I've done this. So a actor pointer spawned actor equals get world. Helps if I could spell world. Spawn actor, and we want this sad.value dot actor class static class, and then we want to use the sad.value dot actor transform, and that's going to put it in the world. Oh, what are we doing? U class, what am I missing here? The value actor class, static class, that part's right. Oh, that's, yeah. And that's because it takes a pointer to a constant F transform. And then I want to go I save actor interface pointer enter equals cast to I save actor interface, and this is logic we're going to be adding in the next episode. I just want to add this now. Spawned actor, thank you, if enter no pointer, continue. Otherwise, call set actor GUID. There's a reason for this, and like I said, we'll cover this in the next episode, but I just didn't want to miss this part. So now we've done this. The next thing we're going to do is pretty much the exact opposite of what we did in the save logic. Instead of getting every actor in the world, and if it's saved using the save interface, we're going to pull the information from. We're going to get every actor in the world, and if it's using the save information, the save actor interface, we're going to push the information to it. So for that, we're going to go for f actor iterator it, same as before, and then it's get world, if I could spell world, it, and increment it. Increment it. I can't even keep my casings consistent. And I'm using, it's been a long day today. There we go. So, same as before, a actor pointer actor equals a pointer to the iterator. If is valid, actor, or doesn't actor implements save actor interface. We're going to continue. And this is one of the things I had done that I actually didn't like. I wanted to refactor in my previous attempt. So if saveable actor data dot find, oh nope, sorry, I missed a step here. So save actor, I save actor interface pointer enter equals cast. Actually, I'm just going actor if enter equals null pointer, continue. So now, as I was saying, if this is one of the things I wanted to refactor, so I'm going to use the new method I was working on. So if save actor saveable actor data dot find wow, I'm really not with it. fGUID dot save actor ID equals enter dot get actor save ID. And so this right here is the reason why we are going to be calling a set actor GUID. If not savable actor data dot find sad. So this is one of the things I was iterating in my previous attempt. I was iterating through every single one of these to see if it matched. Where this, it's actually a quicker function doing it this way than doing the iteration that I was. So let me just do this. So now that we've found that, we know the savable actor data contains this particular actor's information. We can now apply some additional information. So we can go f save actor data sad. Nope. Save actor ID. Fix this. Equals savable dot Oh. And I just hit the build button, cancel that. I say aye. So we know it's in there. We can pull it out at this point. And then we can go actor dot set transform. Sad dot actor transform. And now we want to do the opposite with that memory writer. We want a memory reader. So we want f memory reader, mem reader, sad dot byte data, and then we want f object name string proxy archive ar mem reader, and again true. ar is save game equals true. Actor serialize ar, and then this is also I'm gonna add a comment in here. So it's at this point, if you do have any data that's not being correctly saved with the save logic, you would call that functionality at this point, because all of this other serialized information has been applied. And at that point, that's the end of this for loop. It will go through to the next actor and rinse and repeat. And again, like I said, through my testing, this still is incredibly fast, even with like 10, 20, 30,000 actors in the world. So now we have added this functionality. I'm going to say I'm going to call this episode here. It's already hit pretty long. Actually, no, I will finish this off. I'm not going to leave you guys on a cliffhanger. So let's add in another dev function. Game instance, blueprint callable, void dev load game. We'll get this finished up and then I'll end the episode, because I know I hate when you get a cliffhanger. So for our load game logic, we already have where to go. This part here, it's pulling in that information. So all we're going to do here is call load game. Well, build quickly. Again, this should be a pretty quick build. We haven't changed many files. But just in case, I'll pause this and I will be back once the build is complete. I paused the video and the build finished, so we're good there. Let's launch the editor. Hopefully this is just as quick. It's loading pretty fast, so I shouldn't have to pause the video. All right, let's just open up the player character again, blueprint quickly, and add in some more debug logic. When this loads, there we go. Oh, come on, keyboard event. Keyboard event. I'm going to use 9 here. Thankfully, we can reuse this and go dev load game. So simple as that. We're going to compile. We're going to save. Now, just because, as I mentioned with that whole GUID situation, there is going to be an error if I hit load right away. So we're going to run in editor. We're going to hit 7 to save. We're going to continue through to skip that. Skip that. Okay, actually I want to throw a breakpoint there because I didn't add one there. I'll add one there just in case. Get rid of that one. Get rid of that one because we know that is working. Okay, so that saved. Now let's hit load. So we're going to hit load game, step into that. Save game name is default. Does it exist? Yes, it does. So right now you can see we have one actor in there. We're going to clear that out. It's now empty. We have a new save game object that we have loaded. You can see there is in this object before we, like right here, you can see this is still empty, but in our save game object, you can see we do have one entry. And now we have one entry here. So this is going to iterate through it really quick. Dot value was spawned false. So I'm not going to do anything there. So next thing I'm going to do is put a breakpoint here. We're just going to continue. So we can see our actor is our blueprint third person character. Step through that. Interface isn't null. Do not directly call event functions and interface. I used the wrong one. So let's go to, and that is where we're using the implementation. I made the wrong one there, so let's try this again. Go back to the editor, stop. Let's see if it's going to catch that with live coding. Yes, it did. That worked. Okay, so we'll try that again. So again, we're going to save. It's saved. I need to add some messaging there for that. Actually, I'm going to run over here, hop up here, save, just to show you guys it's actually working. So we're up on the corner of that block there. So we're going to hit F9. Ignore changes. Source files. Yeah. That is just because of the change here. So we're going to hit continue. There we go. You can see it's loaded up that. It was in our saved actor information, so we're going to grab this information. Got our transform and everything. We're going to set the transform, load in the byte data, and there's actually nothing in there. So we're done. We're going to just continue out of here. This should bring us back to the editor, and you can see we've loaded back up here. Now, I just want to check to see, because this was an issue I had in previous games. Our stat line wasn't saving properly. Let's try this again. Hunger and thirst are pretty much gone. So we're going to do that. I'm going to remove that breakpoint. Just continue. Remove that one. Remove that one. And yeah, so that is what I was saying. You can see our hunger and thirst in the top left there. Well, thirst and hunger are now gone. We'll hit load again. None of that information is actually being reset properly. So that is something that's not being saved as part of the serialization. We will need to work on that. But that is something we're going to work on next episode. Thanks for watching, folks. I hope you've enjoyed and learned something. As always, any questions or comments or suggestions, please feel free to add them to the comments. And with that, I will see you in the next episode.